Hello everyone. In this video, we are going to discuss about the superposition theorem. The superposition theorem states that in any linear network, so linear network means the voltage is proportional to the current, output is proportional to the input. In any linear network comprising of two or more sources, the response in any element, okay, the response in any element means the current flowing through that particular element or the voltage across that particular element is equal to the algebraic sum of the responses. Here the responses means either the current or the voltage, okay, caused by the individual sources acting alone. So say for example, if we consider a circuit like this, if we consider a DC circuit, here we have one resistor, here we have three resistors and two sources. One is the current source, another one is the voltage source. Okay, so let this be the voltage source V1 and this be the current source I1. And these are the resistors R1, R2, R3. Suppose we are going to find out the current flowing through this R3 resistor using superposition theorem. So for that, the theorem states that this V1 will contribute some current to this R3 when it is acting alone. So that means this I1 should be made 0. So when this I1 is made 0, this V1 will be contributing some amount of current to R3. Similarly, when V1 is made 0, I1 will be contributing some amount of current to R3. Okay. So now, according to this theorem, the total current flowing through this R3 will be equal to current flowing through R3 when V1 is acting alone plus current flowing through R3 when I1 is acting alone. Okay. In both the cases, the other sources should be made 0. Suppose V1 is acting alone, I should be made 0. So the current source is made 0 when it is open circuited. When I is acting alone, the voltage should be made 0. So the voltage is made 0 by short circuiting. Okay. So this is the statement. So I repeat this. The superposition theorem states that in any linear network containing two or more sources, suppose we have one more source here. Okay. In that case, what we have to do? When V1 is acting alone, the other two sources should be made 0. Okay. So the response in any element is equal to the algebraic sum of the responses caused by the individual sources acting alone, while other sources are non-operative. So at a time, only one source has to be operative. The other two sources are to be made 0. So while considering the effect of the individual sources, the other ideal sources, either the voltage source or the current source should be made 0. That is, voltage source should be replaced by a short circuit and the current source should be replaced by an open circuit. Okay. So this theorem is valid only for the linear systems. Linear systems means the output is always proportional to the input. Next, we will solve one simple problem. So the question is, find the current IL for the circuit shown in the figure below using superposition theorem. So this is a circuit given. Here we have one voltage source and one current source. Okay. And we have three resistors, 6 ohms, 10 ohms and 8 ohms resistor. So we have to find out the current IL flowing through this 8 ohms resistor by using superposition theorem. Okay. So as we have already discussed, so the current flowing through this 8 ohms resistor is contributed by both the voltage source as well as the current source. Okay. So first we have to find out the current contributed by the voltage source with the current source made 0. Okay. So second we have to make the voltage source 0 and find the current through this 8 ohms resistor with only this current source. Okay. Finally we have to add both the currents. So first in case 1, we will consider only the voltage source. Okay. With 28 volts. With 28 volt source only. Okay. So now the current source 28 ampere should be made 0. So for making the current 0, we have to make the circuit open. Okay. So now we are going to open this so that the current will be made 0. So remaining things will be same. So this is 28 volts, 6 ohms, 10 ohm and this is 8 ohm. So the current direction is given in the downward direction. So we will assume it as such only. Okay. So here this loop is open. So no current will flow. So the current will flow only in this loop. Okay. So now we'll assume a current flowing in this loop in the clockwise direction. Okay. It is always advisable to assume the current in clockwise direction. Okay. So now we'll apply Kirchhoff's voltage law here. So by Kirchhoff's voltage law, sum of the voltage rise is equal to sum of the voltage drops in a closed circuit. Okay. So the voltage rise is written only with respect to the voltage source, and the voltages across the resistors are considered as voltage drops. Okay. So the current direction assumed is from negative to positive with respect to voltage source. Then it is written as a voltage rise. Okay. Here 28 volt source is the voltage rise. And then we have to find out the voltage drop across 6 ohms resistor and 8 ohms resistor. Then we have to add both these things. So sum of the voltage drops is equal to voltage drop across the 6 ohms resistor by applying Ohm's law. V is equal to I into R. So current is I and R value is 6. So 6 into I plus current flowing through this voltage, 8 ohms resistor is again I only. So this I and IL1, IL suffix 1 are in the same direction. So if you see here, I is assumed in the clockwise direction. So and it will flow in the downward direction through this 8 ohms resistor. And the given current is also in the same direction. So I will be equal to IL1 suffix 1. So it can be written as 8 into I. So adding these two, we will get 14 into I. So by Kirchhoff's voltage law, we can equate these two. So 14 into I is equal to 28, or I is equal to 28 by 14 is equal to 2 ampere. So in this case, IL suffix 1 is nothing but I. Both are in the same direction. If it is in the opposite direction, then we have to include a negative sign here. So since it is in the same direction, so we are writing it as plus 2 ampere. So let this be equation 1. So next we have to find out the current using the current source only, 28 ampere source only. Here the voltage source is made 0 in the second case. For making the voltage source 0, we have to short circuit it. So short circuiting the voltage source, the remaining things will be the same. Okay. So now the current source 28 ampere. So in this case, let us assume the current flowing through this V, IL suffix 2. Okay. So this is 8 ohms, this is 10, this is 6. So now we have two loops. Here since it is short circuited, it is a closed loop. And here also we have a loop, another loop. So we have two loops in this case. So we'll have to assume two currents, I1 and I2, flowing in the clockwise direction. Always assume the currents in clockwise directions using mesh analysis. So this is mesh analysis. So now we are writing the equation for mesh 1. So in mesh 1, I1 is the current flowing in the clockwise direction. Here we do not have any voltage source. So voltage rise is 0. So now we have to find out the voltage drops. The voltage drop across 6 ohms resistor is 6I. And voltage drop across 8 ohms resistor is I1 minus I2 or I2 minus I1. This 8 ohms resistor is lying in between mesh 1 and mesh 2. Okay. So the current flowing through this 8 ohms resistor can be written as I1 minus I2 or I2 minus I1. So while writing for mesh 1, we have to consider this as I1 minus I2 only. So on simplification, this is I1, right? So 6I1 plus 8I1 minus 8I2. So on simplification, 14I1 minus 8I2. So the KVL equation for mesh 1 is 14I1 minus 8I2 equal to 0. So let this be second equation. So next, mesh 2. Mesh 2 here is a super mesh. So if a current source is present in a mesh on the outer periphery, if you see the circuit here, so this current source is present on the outer periphery of mesh 2. So this is considered as super mesh. So if it is a super mesh, then we have to directly equate this current to the current source. So if you see the direction again, this I2 is assumed in the clockwise direction. So it will flow in the downward direction. Okay, the direction of I2 and the current source directions are in the same direction, sir. So we can directly equate this I2 to 28. So we can write I2 is equal to 28 ampere. Okay, this is equation number 4. Equation number 3. Okay, so now we'll substitute equation number 3 in equation number 2. So we know that equation number 2 from the previous slide, this is 14I1 minus 8I2 equal to 0. 14I1 minus 8I2 equal to 0. So now we'll substitute the value of I2, that is 28 here. So 14I1 minus 8 into 28 equal to 0. So this is 14I1 minus 224 equal to 0. So 14I1 equal to 224. I1 is equal to 224 divided by 14. So this will be equal to 16 ampere. Okay. So let this be equation number 4. Okay. So now if you see the case 2 circuit, here IL suffix 2 is lying in between two mesh. Okay. So through this branch, both I1 and I2 will be flowing. So this IL suffix 2 can be written as either I1 minus I2 or I2 minus I1. But if you see the direction of IL suffix 2, so this direction is same as that of I1. Okay, so if you see here, so this I1 is flowing in the clockwise direction. So it will flow downwards and I2 will be in the opposite direction. So IL suffix 2 can be written as IL suffix 2 can be written as IL1 minus IL2. Sorry, I1 minus I2. I1 minus I2. So in this case, I1 is 16 and I2 is 28. So on subtracting these two, we'll get minus 12 ampere. So this is current in case 2. So already we have found out current in case 1, that is 2 ampere. Okay. So now we have to find out the total current by adding these two. Now the total current is IL suffix 1 plus IL suffix 2. This is equal to 2 minus 12. So that is equal to minus 10 ampere. This is the answer. So the minus sign indicates that the current direction is assumed in the wrong manner. Okay, actually the current will have to flow in the upward direction, but it is marked in the downward direction. So this is the answer. Now we'll solve the second one. The question is determine the voltage V in the circuit using superposition theorem. So here a similar kind of a problem. Here we have one voltage source and one current source. Okay, and two resistor. So now we have to find out the voltage using this superposition theorem. So case 1, as usual, we'll consider the voltage source. So this is with 6 volts. 6 volt source only, making this 3 ampere source as 0. Okay, we'll keep the 6 volt source as such and open this one. Okay, current source is made 0 by opening the circuit. So this is made 0. So this is 4 ohms and 8 ohms. So now in the first case, we'll consider V suffix I is a V suffix 1. Actually is a voltage across this 4 ohms resistor in case 1. So here this is open. So current is 0. Here we have only one loop. And so we can write the mesh equation here. Okay. So for this voltage rises 6. So the direction of the current is from negative to positive. So always assume the current in clockwise direction. So it is flowing from negative to positive. So it is voltage rise. So if it is flowing in the opposite direction, that is from positive to negative, then it is considered as voltage drop only. So now we have to consider the voltages across the resistors as voltage drops. So some of the voltage drops are 8I plus 4I. This is equal to 12I. So by KVL, sum of the voltage drop is equal to sum of the voltage rise. So 12I is equal to 6. I is equal to 6 by 12 or 1 by 2, 0.5 ampere. So 0.5 ampere is the current flowing through this 4 ohms resistor. But we have to find out the voltage across this 4 ohms resistor. So by Ohm's law, V is equal to I into R. So I is 0.5 and R is 4. Okay. So this is 2 volts. So this is the voltage in first case. So next we will consider case 2. So in this case we are going to make the voltage source 0 and finding out the voltage across 4 ohms resistor using 3 ampere source. Okay. So to make the voltage source 0, we have to short circuit it. So the remaining things are same. So here it is 8 ohms and this will remain the same 4 ohm. And voltage is assumed as V suffix 2. Okay. So this current source will remain the same. Okay. So now these two resistors are, that is 8 ohms resistor and 4 ohms resistors are connected in parallel. Okay. Both the ends are connected. See the upper end. Also, if we short circuit it, this lower end is also getting connected with each other. So this can be redrawn as 8 ohms resistor connected in parallel with 4 ohms resistor across a current source. So this current source value is 3 ampere. So this is 3 ampere source. Okay. So now we can apply current division rule. Okay. So we can apply current division rule. So whenever two resistors are in parallel, okay, so we can find out the current using current division rule. Okay, suppose this is I1 and this is I2 and this is total current I. So now I1 can be written as, we need I1 only because we have to find out the voltage across 4 ohms resistor. So this I1 can be written as total current I into opposite value of resistor divided by sum of the resistors. Okay. So I value is 3 total current multiplied by opposite value of resistor divided by sum of the resistors 8 plus 2, 12. So on simplification, this I1 will be equal to 2 ampere. Okay. So let this be second equation. Now the voltage across the 4 ohms resistor in second case is V suffix 2. Okay. That is equal to 4 into 2. That is 8 ohms. Now the total voltage V by superposition theorem is V suffix 1 plus V suffix 2. So V suffix 1 is 2 plus V suffix 2 is 8. So 2 plus 8 is 10 volts. So 10 volts is the answer.